So where we use the factor theorem and where do we use long division? So the kind of questions that you get in your papers have to do with factorizing polynomials completely, and sometimes they have to do with finding missing constants in a polynomial expression. So I'm going to show you a few examples where we use long division and the factor theorem to factorize polynomials. Okay, so let's take an example. The first one, f of x is given as x cubed minus x squared minus 3x plus 2. And the question is, show that x minus 2 is a factor. And then the second part is solve f of x equal to 0. Okay, so the first thing we're going to do is show that it's a factor. Now show that x minus 2 is a factor. Now remember that if x minus, according to the factor theorem, if x minus 2 is a factor, then f of 2 is equal to a remainder 0. I'm going to repeat that. The factor theorem says that if x minus 2, that's this, is a factor, then if you input 2 into the function, you should get a remainder 0. So we're going to apply this. F of 2 is 2 cubed minus 2 squared minus 3x plus 2. So that gives me 8 minus 4 minus 3 into, sorry, I didn't put the 2 in here, 2 plus 2, which is 8 minus 4 is 4 minus 6 plus 2, that is 0. Okay, so we've shown that f of 2 is 0, therefore x minus 2 is a factor. That's the first part of the question, show that x minus 2 is a factor. Now we're going to do the second part, which says solve. Solve f of x is equal to 0. So what this means is we have to find the remaining factors and the corresponding roots of the equation. Now, once you know one of the factors, what you can do is do a long division, and the quotient of the long division becomes the remaining factor of the polynomial. So our original factor was x minus 2, and f of x is x cubed minus x squared minus 3x plus 2. So what we want to do now is do the long division in order to get the remaining factor. So I'm just going to explain this. Suppose you have the number 6, you want to find its factors, and you already know that 3 is one of its factors. So if I divide 6 by 3, I get the quotient as 2. So this is the second factor. 3 was the first factor, we did a long division and got the second factor. So we're doing something similar here with the polynomial, which is divided by the first factor, which was already given to us and which we proved is a factor by using the factor theorem. And then the quotient that we get will be the remaining factor. So x goes x squared times into x cubed, so x cubed minus 2x squared minus plus, and this becomes x squared minus 3x. So x gets multiplied by another x to get x squared minus 2x. Change the sign. This is minus x plus 2. I'm going to write here x into minus 1 gives me minus x, and minus 2 into minus 1 gives me plus 2. Change the signs for subtraction and everything cancels out. Remainder is 0 because we already showed that x minus 2 is a factor. So x squared plus x minus 1 is the remaining factor. So our f of x can be written in factorized form as x minus 2 and x squared plus x minus 1. Now since this is a quadratic factor, I can check using the quadratic function on my calculator to see if I can factorize that further. So I'm going to put in the values 1, 1 and minus 1. And I don't get any rational factors, and therefore I'm just going to leave it like this. If I wanted to find the roots, of course, one of the roots would be 2, and using your calculator, the remaining roots would be minus 1 plus minus root of 5 the whole by 2. Of question. P of x is given as 2x cubed minus x squared plus ax minus 6, and it's given, so we don't have to prove it, it is given that x plus 2 is a factor, and we are tasked with finding a and then factorize it completely. Okay, so given that x plus 2 is a factor, in order to find a, we can use the factor theorem. So if x plus 2 is a factor equated to 0, you will get the root as minus 2. Plug this in. So p of minus 2 should be equal to 0 because it's a factor and it's told to us, I mean it's a given. So p of minus 2 would be 2 into minus 2 the whole cubed minus minus 2 squared plus a times minus 2 minus 6. That is negative 16. The minus gets squared and becomes plus, so that's a minus 4 minus 2a minus 6 is equal to 0 because it's a factor. So I get minus 16 minus 4 is minus 20, minus 6 is minus 26 is equal to 2a, and a is minus 13. So we found the value of a, that was our first task, and now we're going to factorize p of x completely. So I'm going to do it here on the right side. So in order to factorize completely, what do? We do a long division to find the remaining factors. So x plus 2 is the divisor, the polynomial is 2x cubed minus x squared. I know the value of a, so I'm going to write it as minus 13x minus 6. X multiplies into 2x squared to give us 2x cubed plus 2 into this would give me 4x squared. Change the signs. Minus 5x squared minus 13x. X goes minus 5x times. So I'm left with minus 5x squared. 2 into minus 5 is minus 10x. Change the signs. That's minus 3x minus 6. X goes minus 3 times to give us minus 3x. 2 into minus 3 gives me minus 6. This was expected because it's a factor and there should be no remainder. Okay, By doing the long division using the one known factor, we end up with the remaining factor. So we can write P of x is x plus 2 into 2x squared minus 5x minus 3. Once again, it's a quadratic, and I would like to check if it can be factorized further. So I'm putting it in my calculator in the quadratic function. So 2 minus 5 and minus 3 gives me 2 roots, x equal to 3 and x equal to minus half. So this gives me x equal to 3 and x equal to minus half. Okay, so the factors of P of x are now going to be the first factor, which is x plus 2, and x equal to 3 is the root. If I wanted to write it as a factor, I write it as x minus 3, and x equal to minus half is a root. If I wanted to write it as a factor, I would write it as x minus half, which is basically x plus half. So this is the complete factorization of P of x.